Prove that if xy equal to 1 plus log y in base a, then y squared plus bracket xy minus 1, close the bracket, the y dx equal to 0. Solution. We're going to differentiate this and then arrive at this being equal to 0. In order to prove this, you must know the formula to apply. On the left-hand side, we're going to use the product rule. So we are going to write down the first and differentiate the second. So we have x dot differentiating y is the y, the x, plus we differentiate the first and write down the second. Differentiating x is 1 dot write down y equal to, on the right hand side, 1 is a constant. So to differentiate 1, that will be 0, plus differentiating log y in base e, we have 1 all over y, the y, the x. The next thing is to arrange them well. We have x, the y, the x, plus y equal to, this will be 0, and what will be left here is 1 all over y, the y, the x. The next thing is to multiply through by y. So while we multiply this, we have xy, the y, the x, plus y times y, y squared, equal to y times 1 all over y, the y, the x, so that this will cancel this. We have xy, the y, the x, plus y squared equal to the y, the x. The next thing is to collect the like terms. But meanwhile, this is the same thing as y squared plus xy, the y, the x. This will cross the equality sign to the left-hand side, and that will be negative, so that only 0 will be left here. So we have minus the y, the x equal to 0. So we are going to factorize. We have y squared plus, now the common thing here is the y, the x. So in bracket, we have xy minus 1, the y, the x equal to 0. And this is exactly what we were asked to prove.